now we are going to see the types of queues. Number one, we have circular queue, okay, and then we have D queue, right, and then priority queue, and then one multiple queue. Okay, right. So what is circular queue? Why are we going for circular queue? See, in an array, right? Say for example, if I have something like this, okay, let it be a 5, 6, 7, 8, no problem. Okay, let me just drop it here. Okay, right. So let it be 5, 6, 7, 8, 9, 10. Okay, suppose if I delete this, assume the first two is empty, right? So if I use an array, I cannot use that first two position, right? Which means it's a waste of memory. Okay, so to avoid that, we are making the queue as circular queue. Okay, we are making the queue as circular queue. So what's the front here? Here front equal to 2 and rear is equal to 9. Okay, fine. So what happens? So the major drawback here in the linear queue is it will waste the memory. So to resolve this problem, we have two solutions. First, we have to shift all the elements to the left side. Okay, what is the solution we have? The solution we have, the first solution is shift all the elements to the left side. Okay, right? Otherwise, what's the next? So the second option is use circular queue. Circular queue. Okay, what's the plus of this? Right, it saves in memory. So here the first index comes right after the last index. Okay, so the first index will be next to the last index. Okay, so it will save the vacant location. Okay, it will save the vacant location. So suppose if front is equal to 0, right, and the rear is equal to max minus 1, then the circular queue is full. Okay, right. Suppose if front is equal to 0 and rear is equal to max minus 1. Okay, so this is what the circular queue is full. If the rear is not equal to max minus 1, then the rear will be incremented and it will be inserted. If front is not equal to 0, okay, and max is minus 1, what about this condition? Can you tell me? Just think, front is not equal to 0. Front is not equal to 0 means what? Front is not in the first position. Okay, and rear is equal to max minus 1. We know that rear is max minus 1 means it's full. But here, this is also full. Okay, but this also says full. But actually it is not full. Am I right? Why? Actually this is not full. Because front is not equal to 0 means I have something before that. Am I right? Here also the front is not equal to 0. But I have some data before. I have some space before that. But if you check this condition, it becomes what? It says it's full, but actually it is not full. Okay, so that is why we need to make it as a circular queue. Okay, so if we do that, so as usual, right, what we have to add is we have to make, if rear is max equal to max minus 1, and front is not equal to 0, just make the rear as 0. So what happens if you make a rear as 0, which means I can insert it, right? Because if I increment, so say for example, after I'm seeing that front is not equal to 0 and the rear is full, okay, but I have this space. How can how can I insert element here? I have to make the rear as 0. Then as usual you have to increment the rear and then insert the data. Okay, right? So this is how you can insert the data in the circular queues. This is how the circular queue saves your time. Okay, and what is DQ? The DQ is called a double-ended queue. Okay, so next we'll see double-ended queue or DQ. Right? In which the elements can be inserted or deleted at either end. Elements can be inserted and deleted at either end. Okay, this is special queue, right? So in a normal queue, we can insert only at the last and delete at the first. Okay, so here the specialty is you can delete at either end. Okay, so there is an input restricted queue and it has two types. One is input restricted queue. Okay, so insertion can be done only at one of the end. Insertion can be done only at one of the end. And output restricted DQ. Okay, so here relation can be done only at one of the end. Okay, so this is what DQ. Okay, and what is priority queue? Here the element will be stored something like this. It'll have, usually node will have what, 3, right? But here each node will have 3 parts. One is data part, other one is priority and the address to the next node. Okay, so suppose if I have, assume that this is a node. Okay, suppose if I have a node X, okay, and its priority is 1, right? And this is the pointer to the next node. So it will be like, it will be pointed to the next node. I think that just let me put it like an arrow. Okay, pointed to the next node. So I can insert any element based upon the priority. Okay, so this is what a priority queue. Okay, so it can be represented in the linked list implementation. Okay, right? So x1 the same way you can put x2. I don't know whether I can paste it here or not. Okay, I have data y and another node, paste it, is it. Okay, so this is priority 1, this is priority 2, and this is priority 3. Okay, suppose if any new node comes, right, it will add the priority based upon that. Okay, suppose if any node comes with a priority 5, okay, so what will happen, it will insert after the 3. The least will be taken as the highest priority, So what's least here? Least is 1. That is the highest priority. Okay. If any node comes with 5, it will be inserted after the Z. Okay. So this is how we can represent the priority queue. Next is multiple queue, right? So multiple queue. This is actually priority queue. Okay, multiple queue, right? In multiple queue, okay, when we implement a queue using array, right, the size of the array must be known in advance. But if the queue is allocated less space, then the frequent overflow condition will happen. So to deal with that, okay, we have to reallocate more number of spaces. So if you allocate a large amount of space for the queue, it will result in less wastage of memory. So it lies in the trade-off between the frequency of overflow and the space allocation. So what's the best solution for this? Okay, right? So say for example, I have a QA, QB. Okay, the Q of the value of the n in such a way that the combination of or the combined size of both the Q will never exceed n. So while operate, so QA and QB, right? So while operating on these queue, it is important to note that the QA will grow from left to right. The QB will grow from right to left. So extending the concept to multiple queue, a queue also can be represented as n number of queues in the same array. That is, if we have a queue of n, then the queue of I will be allocated an equal amount of space bounded by the indices b of I and e of I. So say for example, let me take this one. As the this is priority queue and this is multiple queue. Okay, so assume that I have nothing here. Let me just delete everything. Okay, so this is okay, and this will be n minus 4. This will be n minus 2. This will be n minus 3. This will be n minus 4. And this minus 1. Okay, so this is what multiple queue. That's why they assume that this is for QA. This is QB. Okay, so I have two queues. One is QA, other one is QB. Okay, QB grows left. Okay, and the QA grows right. Okay, so we have multiple queues in this. Okay, so this is what the types of queue that we have. Each queue has different solutions. Okay, right? So what is a priority queue? Let me just type the content now. So it is a data structure in which each element is assigned a priority. Okay, so the priority of the element will be used to determine the in which the elements will be processed, right? So there are two things. So the node structure. So an element, okay, its higher priority is processed before the higher priority is processed before the lowest priority element. Priority, one more R. Okay, so the two elements, suppose if I have the elements, if two elements having same priority, okay, or processed on the first to come first to serve basis. Okay, so it's actually a modified queue. Okay, so that's what I represented in the diagram. Okay, so x1, so first 3 is the first element, and the next 3 is the second element, next 3 is the third element. Okay, right? So if a 7 comes, if for example A comes with priority 3, okay, whichever comes first will be processed first. Got it? Now what is the multiple queues? Right? So here the queue is represented as two queues. I is represented as two queues, like QA, like QA and B. Okay, right? So the size is the combination of both Q, A and B. Okay, and next we are going to see a tree. Okay, what is tree? A tree is defined as set of one or more node is designated as the root of the tree, and all the remaining nodes, okay, all the remaining nodes can be partitioned into non-empty sets, each of which is subtree of the root. Each of which is the subtree of the root. Okay, so what are the basic terminology? So we have one root node. Okay, one root node and many child node. Okay, so what are the basic terminology that we have? First is root node. Okay, this is the topmost node in the tree. If this is null, then tree is empty. Next is subtrees. Okay, the left child and right child of the root is called subtree. What is called a leaf node? The node which does not have child node is called root node. What is path? The path means consecutive edges is called path. Okay, next is in degree. It is number of edges arriving at the node. Out degree, number of edges leaving the node. Okay, it's called the out degree. So this is basic terminology. Okay, so we have a types of trees like binary tree, binary search tree. Okay, so suppose if I have, okay, so here A is the root node. What is the in degree of the root node? B, C, D. What's out degree? That also A, B, C, because it is unidirectional, right? What is a leaf node? The leaf node is a node which does not have a child node. So F does not have child, K does not have child, L does not have child, H, I, J does not have child, and B does not have a child. What is called sibling? The sibling of B is C and D. The sibling of D is B and C. The sibling of H is I and J. The sibling of K is L. Okay, so this is what indeed. What's a path? So this is a root node. The path from A to K is A, C, G, K. This is what path. Okay, and what other terminology we have seen? Yeah, subtree. So B is a subtree, C is a subtree, and D is the subtree. Okay, so these are the terminologies that we have in trees. So what's a root node here? The root node is A. And what are the child nodes? It's B, C, B, C, D. Okay, and what are the leaf nodes? The leaf nodes are B, H, I, comma, J. What is the path? What is the path? The path is A, C. The path from leaf node to child node. So A, C, F. This is also a path. Okay. So what is the in degree? What's the in degree of in degree for A? Okay, it is B comma C comma D in degree of A. What is in degree of B? It will be A only. What is the out degree of A? That's also B comma C comma D. B C comma D. Okay. So this is what trees.